a volume of hydrogen, 5.37 liters of hydrogen at temperature equals 509 Kelvin and pressure equal to 2.12 atmospheres with 5.94 liters of oxygen, O2, at temperature equals 357 Kelvin and pressure equals 2.38 atmospheres. How many liters of H2O liquid can be formed at temperature equals 424 Kelvin and pressure equals 1.3 atmospheres? So there's a lot of numbers in this problem. I'm going to go and let's see here. I'm going to go to this one, 312, 313, and I know you can only see part of what I'm showing you here, but in this particular problem, you will have the balanced reaction. So I'm going to go ahead and write that down. And I wanted to check that, because this is a stoichiometry problem, meaning it's a problem in which we will find the moles of H2 from the using the ideal gas law. We'll find the moles of O2, and then it becomes a limiting reactant problem to find out how many moles and then how many liters of H2O liquid we can make. So we'll start with hydrogen, and for hydrogen we have a volume, a temperature, and a pressure, and they're all nicely in the correct units for the ideal gas law. So PV equals nRT. I know I have 2.12 atmospheres. My volume is 5.37 liters. And since I've got a number of things running around here, I am going to label these moles as moles of hydrogen. So much of this course is making sure you keep track of things in a relatively organized way so you can find them later. My R value, 0.08206. And those are units of liter atmospheres per mole Kelvin. And my temperature, 509 Kelvin. I can rearrange this to solve for my moles of hydrogen. And if I do that, I need to take these two, divide them by the ones on hydrogen's side to solve for N. 2.12 divided by 2.12 times 5.37. There we go. Divided by 0.08206 divided by 509 equals 0.273. moles of hydrogen. And this time we have 2 to 1. We have stoichiometry. That means that if I'm going to find the limiting reactant, I do have to actually go all the way to moles of product at least. For hydrogen, I know for every 2 moles of hydrogen reacted, there are 2 moles of H2O produced. So the number stays the same, but I convert my units into moles of H2O. Now let's do the same thing except for oxygen, and I'll give myself even a little more room here. For oxygen, I'm going to do a PV equals nRT as well. I'll put the problem statement back on the video. I have let me write it out. I have 2.38 atmospheres. I have 5.94 liters. My R is the same, and my temperature is 357 Kelvin. And rearranging this, 2.38 times 5.94 divided by 0.08206 divided by 357. 0.483 moles. Moles of oxygen. And so one thing I'll say about this is if you get to moles of oxygen and you can see that it's larger than your moles of hydrogen, and you know that it produces double the moles of H2O, you can tell right away that hydrogen is your limiting reactant and oxygen is your excess reactant. Or you can go ahead and show it, but if you got to this point and you did not, and you just wrote hydrogen is the limiting reactant, that would be fine. I'm going to go all the way. Because what if you didn't notice that? And it's always nice to compare apples to apples, meaning moles of H2O to moles of H2O. I get 0.483 times 2. I get 0.966. Moles of H2O. Then I circle my moles of H2O here because that's the actual moles I can produce. Of course, it's always the smaller amount. And nobody asked me, but if they did, I would say hydrogen is my limiting reactant. Let's come back to the problem statement. It says how many liters of H2O liquid can be formed at 424 Kelvin and 1.3 atmospheres. So these are the moles made because it's the smaller amount. Now I have to do another ideal gas law, this time for H2O. And again, I know my temperature and my pressure, and I know my moles. The only thing I don't know is my volume, which is what we're asking for. This time, I got my ideal gas law. I know I have 0.273 moles. I know my R value. And the R value, which is on your conversions and equation sheet, but perhaps we will use it enough so we will end up memorizing it, at least for this semester. I don't know. From the problem statement, temperature is 424 Kelvin. And my volume, I don't know. That's what I'm solving for. And my pressure is 1.3 atmospheres. So rearranging to solve for volume, it's going to be each of the terms on the right-hand side multiplied together. Divide by 1.3 atmospheres, and I get 7.31 liters. And 7.31 liters is a fine answer. Liters of H2O liquid is also a fine answer, but it's not like molarity where I need you to write the solute. So this one would be 7.31 liters. Oh. Ha. So there is one typo in this problem, which is that the H2O has to be a gas. And it would be at 424 Kelvin because 424 is above the boiling point. So I think this reaction way up at the top should say gas here, because it has to be a gas if we're using the ideal gas law. Let's go back for a second. Oh, it does say liquid. That is a typo. It is supposed to be gas because we're using the ideal gas law, and the only time the ideal gas law works is for gases. and this is 13. So I will go back in and change it to gas. At some point. No promises by the time you turn in your homework, but it's on my list, my long-term list of things to do. Any questions about this problem?